Hello students, this is Professor Chalai, and in this lab we're going to go over some of the things that you would need to know for the Bromination Kinetics lab. The bromination of acetone reaction is shown here, where we have the reaction of bromine gas with acetone, an acid, to form the products shown here. Our aim in this lab is to come up with the rate equation for this reaction, including the rate constant K and the rate orders for bromine, let's call that A, for acetone, let's call that B, and for acid, let's call that C. So we need to figure out the rate constants and the rate orders A, B, and C. Now how are we going to do this? Well, to do this we need to come up with a table of data to solve for A, B, and C and K like we did in class. So we need a table where we have initial concentration of Br2, let's call it Br2I for initial, acetone initial concentration, and H acid initial concentration, and then initial rate. These initial concentrations will be given in molarity, so that initial rate will be given in molars per second. So these are all molarity. And we'll have to do this experiment multiple times to get enough data to fill this table so that we can solve for each of our unknown. Let's focus on each of these individually. How would we figure out our initial concentration of each of our components? Well, the way we're going to do this is we're going to have each of our reactants in stock bottles, right, with some stock concentration. In the case of bromine, I think the stock concentration of bromine that we're going to use is 0.020 molars of bromine. There we go. And then we're going to take some amount of this stock solution. In the first trial, for example, we're going to use 5 milliliters of bromine, and then we're going to add it to our reaction. Well, we're going to go through the details of how we're going to add that a little bit later down. But we're also going to add all the other reactants, acetone and acid, and some water, so that the total volume here will be some specific number, right? Total volume. In most cases, that'll be 25.00 milliliters. So the initial concentration that we're talking about here for each of the trials is not the stock initial concentration, but rather we need to figure that out by figuring out how many moles of bromine did we use. So in this case, the moles of bromine would be our 5 milliliters that we took. Let's convert that to liters, times our starting concentration in the stock solution, right? And this will give us an initial mole of 0.00010 moles. And if the total volume is 25 milliliter, our initial concentration in the reaction, our initial concentration of bromine will be that same 0.00010 moles over our 25.00 milliliters. But of course, since this is molarity, we need this to be in liters, so let me just do that quick conversion as well. I should get a starting or initial concentration of 0.00040 again. That is our initial concentration of bromine. And you'll have to repeat this for each of the different reactants for each of the trials that we're going to do. Okay, so that will fill out all of the initial concentrations on this table. What about the initial rate of this reaction? Well, in this particular reaction, we're going to make sure that the concentration of bromine is much, much smaller than the concentration of all the other things. That way that throughout the course of the reaction, bromine is our limiting reactant, and the other concentrations are so large that we can assume that they don't really drop by much. So we're going to track our concentration of bromine using absorbance. Specifically, absorbance at 395 nanometers. And since bromine is a reactant, as the reaction proceeds, right, the concentration of bromine will drop, and so too will the absorbance of bromine. Now, what we want here is the initial rate. How do we get initial rate out from this graph of absorbance versus time? Time is on the x-axis. Well, we need to get the initial rate so we can ignore a good chunk of this latter half of this reaction that doesn't really follow the trend line of straight line. So we can delete that data and then try to draw an equation plus b, y is equal to mx plus b, from our initial data only. The rest of the data that's not part of that linear trend line we can ignore. Okay, if we think about our rate of reaction, right, bromine is a reactant, right, with a stoichiometric coefficient of 1. So the rate of the reaction here should be negative the rate of change of concentration of bromine over time. Now we're going to assume that the absorbance is directly related to the concentration. So if we think about the slope of this graph, it's, y over x is change of concentration of bromine with time. So that means that basically the rate of reaction is negative the slope. So if once we find our equation straight line for our data from that trial, the negative of that slope will be our initial rate. So for as many trials as you have, you'd have to create this straight line, get the slope, and include that as our initial rate. So once we fill in that table, we should be able to do all of the normal calculations to get the rate orders and the rate constant k. So here are some things that I want you to sort of keep in mind for this particular lab, right? The first is you need to remember to calibrate your spectrovids, your spectrophotometer with deionized water, right? And then you need to remember that in doing so, you only use that one cuvette, right? And the one that you use to calibrate your spectrophotometer. And what we want to measure is absorbance versus time. So we'll need to switch over to absorbance versus time, and we need to choose 395 nanometer as the wavelength to measure this at. The second thing that we want to consider is this reaction is very, very fast, and we want the initial rate of this reaction, right, to put into our table. So we need to only mix our solutions when we're ready to take measurements. So the way we're going to do this is we're going to mix the acetone, HCl, and water first, right? Because if we add bromine in there, that will start the reaction. We will wait until we're ready to add the Br2. So Br2 is only added when we're ready to add it. And when you add the Br2, you have to move fast, right? So you'd add the Br2 to the rest of the reactants. We'll give it a quick swirl to make sure it's all mixed up and reacting. You'll rinse out the cuvette and add your solutions to the cuvette, and then you'll quickly add it to your spectrophotometer and measure the absorbance on the graph. Other things that you would need to consider is, for example, cleanup. So for cleanup, right, all the waste should be placed in a special designated container in the hood, not down the sink. And as always, you rinse and you replace all of your glassware. Okay, these are sort of all the things that I wanted you to keep in mind for this week's lab. As always, I'll see you in lab.